Hi everyone, we're going to graph exponential functions and discuss how they are alike and or different. So the first one we have is y equals 2 to the x. I graphed it in black. Basically, if I do a table here and put x, y, the points I want to use are -1, 0, and 1. I also can use a calculator, but -1 is 2 to the -1, which is 1/2. 0 is going to go to 1, and 1 maps to 2. So here's my graph here. This is the parent function in black. 0 goes to 1, -1 goes to 1/2, and 2. And it doesn't cross we have a horizontal asymptote here at y equals 0. Okay, so this is your first function, f. That's the parent function. Now what we're going to do here is shift this to the right. This is a horizontal shift to the right by 3. So basically on my y, I'm adding 3. No, I'm adding 3 to my x, sorry. So I'm going to do another table here. And if I look at the graph, what I'm doing is I'm shifting this to the right by 3. So I had 3 main points on my parent graph. So from here, I'm going over 3. 1, 2, 3. From this point here, I'm going over 1, 2, 3, making it big so you can see what I'm doing. And then from my -1, I'm going over 3. So -1 plus 3 would be 2. 1, 2, 3. And then you're just shifting this whole graph. Now it's continuous, but it just got shifted over to the right by 3. That's your G. All right. And now, so basically the table would be -1 plus 3, 0 plus 3, 1 plus 3. And that's just what we did. And your y is the same. 1/2, 1, and 2. So that goes with this one. And the red goes with the first one. And now the third one is just like any parent function. The 1/4 is going to be more of a compression. It's going to flatten it out. And what I'm doing is I'm just multiplying by my y by 1/4. So I keep my x's the same, and I multiply my y by 1/4. So 1/4, I'll just write it out. 1/2 times 1/4. 0 times 1/4 is still 0. Then we have 1/4. So this right here is 1/8. So it really flattens it out. So instead of 1/2 here, we're actually a little lower. We still cross, it still has the same y-intercept, but then 1/4 of 4 is 2. So it's flattening out here. So it's kind of lower here, comes up here and flattens out. So that's the one that's just a little flatter than my f, my parent function. Okay? They all have the same domain. The domain is all real numbers. So you can just write all real numbers. The range is y is greater than 0. It kind of looks like it's crossing here, but it's not supposed to. They all have the y-intercept. The y-intercept is 0, 1. And how they're different? Well, f is the parent function. H was a compression by 1/4. And G was a horizontal shift to the right by 3 units. Right? The next one we have we have one more here, is f of x equals 3 times 5 to the x. So this is going to be 1, this is going to be 2. So my first table, I'm going to put x, y, and I'm just going to stick with -1, 0, and 1. We know it's exponential. And on the second graph, I'm going to do the same and just plug these points in. So for this, -1 would be 3 times 5 to the -1, which is 3 over 5. 0 would be 3 times 5 to the 0. 5 to the 0 is 1, so that's just 3. And 1's going to go to 15. Now on this one, -1, so if I have 1/5 to the -1, that is really equal 5. So what happens is this all gets reversed. This is going to be 15, this is 0, and 1 is going to be the 3/5. So what happened is these two trade places, and you see the corresponding graphs here. They're not perfect, but they have the same y-intercept at 0, 3, but this one is going up. It's exponential growth. And my G is actually going down. And that one is exponential decay. Let me write it over here. G would be exponential decay. They both have the same domain and range. And they both have the horizontal asymptote at y equals 0. Okay, thank you and have a nice day. Bye-bye.